My dream is to be able to take titanium, steel, and forge weld them together. I've made up all of these boxes so that once we put our steel and titanium in, we can seal them up and pump inert argon gas through so that at the high temperatures, neither the steel or the titanium will react with the oxygen in the air, causing oxides that will stop them from sticking. Billet 1 is 0.1 millimeter copper, 0.7 millimeter, 2 millimeter. This is a 2 millimeter sheet of nickel, pure silver, that's 0.3 millimeters. Of course, last one's gold. That is very thin. Now gonna cut our 1080 steel. This is a lot of stuff. Our sandwich, steel in the middle, interlayer either side, grade 2 titanium either side of it, and just for fun, grade 5 on the outside. That is going to be our forbidden sandwich. They are all ready to go in the forge, but what I want is 4 rectangles out of everything. Unfortunately, last week, WAZER kindly sent us just the machine for doing that. We got a Waterjet cutter! What? How did you get in there? There's 2 of them. Whoa. Pretty cool, huh? It wasn't just a couple of weeks ago I was talking about how all machines should be designed around how they're going to be lifted. Check this. The side of the crate is an integrated ramp and is built to be moved on the pallet truck. I'm now going to decide where she is going to live. I've been thinking about moving the jewellery bench back into the office for a while. Maybe it could go up against this wall. I think this might be the spot. My goodness. We've got it filled with water and leveled. Now we've just got to switch it on, purge the various systems, make sure there is no air in this, and then I put the included SD card in the machine, and hopefully the first thing we cut is this little datum board. To start cutting, press start. Cut completed. Total cut time 18 minutes. That is delightful. We Waterjet cut parts. This is now a frame that we can use as a datum when we're cutting other stuff. Now we're going to cut something of our own. Cut quality medium. Got our estimated cost. Generate job file. Ooh. Just got to put it on the SD card. Clean this out. In goes the steel. Whoa! Oh my goodness! It's my touch mark. Isn't she beautiful? Back to the topic at hand here. We gotta get these things ready to put in there. Now, I did a little test piece right here in some 7/1000 shim steel, planned out where we're gonna have little tabs, and that's gonna mean that we have symmetrical pieces across the entire range. So let's cut off these handles, make sure they're flat, and mount them up. All right, close door. Start cut. Oh my goodness. We just had it kick off. It's done. What do we have?
Hurry up, man, I'm excited.
I'm trying. I gotta undo the screws. Ugh. Let's break it apart. That is the side of our billet. You can't see anything. Look at that. So that is exactly why we can't weld steel straight to titanium, because that is the mild steel jacket that we made the protective box from, and it just snapped right off. Whoa, that's crazy. I'm excited because it feels like 4 solid bits of metal. If you look ever so close, you can see titanium, copper, steel, copper, titanium. It's not over till we test the stuff, right? But in order to do that, we need to finish the rest of them. So I'm gonna get billet number 2 loaded in the WAZER, then we're gonna clean these up so that we can properly have a look at what we've got. That's crazy. Look at that. You see there's like a bubble in the material. It has separated the mild steel jacket, filled it with pressured water, and then jammed the nozzle That's hilarious. And a jam like that forces water up the abrasive tube, so I've got to clean that out and get back cutting. Waterjet hydroforming. Oh, and it looks like it's stuck! Yes! Just awesome. Look at how wild that is. No way. Billet 6 with the gold foil has completely split apart. Oh! Our first clear as day failure. It didn't even make it to the stress testing. No. Oh! Wow! Decimated it. That titanium could not handle the smoke. Both the grade 2 and grade 5 shattered. So did the bond between the copper and the titanium. There's nothing left of that. Next up. Oh, gosh. At about the same angle as well. But this time that didn't pop off. Interesting. Oh, it's better. Yes! Wow! That withstood the crazy tensile stress here on the outside of the bend way better. The titanium is plastically deformed. See if we can get the whole way to 90 degrees. Oh, brilliant. Number 4. Oh, what? Oh, it just fractured. Just at the final part of the bend. Surprisingly good. It does look like there's a slight delamination happening there. Given our goal of wanting to be able to make a San Mai style blade with a titanium jacket and a carbon steel edge, for test number 2, we are going to harden and temper all our samples to see if they can withstand a heat treat. On goes the power hammer. Quent. That's wild to do. There's the argon bubbling out. That's so cool. All right, we're gonna need to run a slightly different order of operations because obviously I'm not gonna be able to cut the hardened steel and process it to size. And also, if you leave steel hardened but not tempered for too long, the steel itself can break. So we're gonna dump the heat out of the kiln, temper it as soon as possible. And this is then going to be the perfect time to use the Waterjet again because it will be impossible to bandsaw the hardened steel. All right, machine just finished. Now we're going to break the little Kit Kats out. Oh my goodness, that looks like it's welded. The much dirtier mild steel jacket, of course, doesn't look like it's bonded. You see that big line there? But in there, it looks like one piece. That jacket fell right off. Woo! Damn, that's cool. That's direct bonded steel and titanium straight off the WAZER. Oh, that looks good. This looks promising. And that is all of the heat-treated samples, minus those poor fellas. But it is worth noting we have a minor delamination at the top of 2, a minor delamination at the bottom of 5. The delamination on 2 is between the grade 5 and the grade 2 titanium, though. Delamination on 5 is between the steel and the copper. Let's get to testing. Oh my goodness, that was pretty good. Oh, broken the titanium. Oh, there's plenty of delamination though anyway. Madness. Oh, that was bad. No longer attached. That was a delamination between the nickel and the steel. Poor thing. We're obviously not doing 6 and 7. 8, our titanium control. Broke at the grade 5, grade 2 interface. 9, our steel control. I can't pull on it. Oh my gosh! We got delamination. Hey, hey. I guess we found one of the downsides of forge welding steel at 850 degrees Celsius. Look at those insides. Funny little circular features in there. Our direct bond to steel, number 10. Oh my gosh, it's amazing! Ow! No way! No way, what have we done? It's intact! That was hard to pull on. We're looking at a strong contender here. This might be the recipe. Yes! It didn't break at the joint between the steel and the titanium. That is a break at the grade 5 titanium interface with the grade 2 titanium layer. And that was hard to pull. Unbelievable. I can't believe it. I think we've just done something really cool. I think this means we can try making a knife from it. A titanium-clad steel cord knife, and is stronger than hardened steel and stronger than just titanium. Here is all the data that I gathered if you're curious. I'm also going to publish a little post on my website if you want to dive deeper. As ever, I'd love to hear from you. I sincerely appreciate having your time, especially on something as niche as this. Thank you. I hope you have a great day. Bye-bye.